So my name is Arnesh Kundu, and I'm homeschooled actually.
Okay.
Um, I'm in sixth grade.
Where do you live?
West Windsor.
Okay, great, great. So, can you tell me a little bit about your project? And imagine you're trying to explain it to someone in very simple terms who may not be that familiar with the technology. We want to use this video that we're going to post on our website and on YouTube and things, so we want to try to keep it simple.
Okay. So my project is a new NO2 removal system. So current NO2 systems use two methods. Either they use catalytic reduction or large-scale factory settings. But the major contributor for NO2 is actually cars, trucks, and mobile sources, which account to 48% of NO2 emissions. So unless you can find a way to target that 48%, you're not going to solve the problem. Current systems to do that involve catalytic reduction, but those are often very expensive, and the catalyst required are very expensive, like platinum and rhodium. So my system is a new way of doing it. It is a two-step process. In step one, the NO2 is captured from an on-site system, which would so it's a canister that plugs into the back of the car. And in step two, the NO2 is processed and then the NO2 is destroyed, and the cartridge can then be reused. So the way that I stored the NO2 is using activated charcoal. Activated charcoal is regular charcoal, but it has a much higher surface area. This allows it to have more pores for the gas to pass through, and therefore the gas is more likely to get captured in the charcoal. So I connected the charcoal to a snowblower, and the reason I use a snowblower is there's no EPA regulation in snowblowers, so snowblowers emit a lot more NOx than any other vehicle. So I connected the whole thing, and I added a sensor to measure the NO2 concentration, and the results I got were pretty good. So going here, this is the graph.
Okay, I see it
This is
now.
the graph.
Go ahead.
Okay, so this is the graph. It is the NO2 concentration over time. It starts out really low at around 1.5 parts per million, and it stays like that for a long time, almost 75 minutes before climbing and then going to the normal amount, which would be zero point 0.4 ppm. So this was a much bigger reduction in NOx than I expected, and I'm really quite pleased with how it happened. So to measure the NO2, I had to design my own NO2 sensor. Give me a second. Move to there. So this is the final sensor. It uses a mixed 2714 NO2 sensing element, and that sensing element measures the NO2 content in the air, and then there's an Arduino Nano controlling it. So this was definitely one of the hardest parts of my project, designing the sensor, because a lot of commercial NO2 sensors are extremely expensive, and of course I couldn't get those, so I had to try designing my own. And the sensing elements as well, those are designed for factory use. So I solder at home, but I those are in a type called SMD, which is very difficult to solder without a specialized reflow soldering oven, which I didn't have. So it took me a lot of time, but I finally found a good sensor, the Mix 2714, that would work in the harsh conditions in the snowblower's exhaust tailpipe. The conditions would be really cold sometimes. It would get hot. There would be dust. There were a lot of different things that caused issues a lot with the other sensor I tried, which was the Mix 6814. This was definitely the hardest part, measuring the NO2. So the charcoal then, when fully absorbed after 75 minutes, I brought it back to in the house, and then I passed steam through it. So what the steam does, it reacts with the NO2 on the surface of the charcoal, and it basically liberates the NO2 and reacts with it to form a mixture of nitric and nitrous acids. These acids can then I then condense the acids, and those acids were reacted with a strong base. I used sodium hydroxide to create the nitrite and nitrate salts. So nitrite is basically NO2 minus, and the gas I'm trying to remove is just NO2. So it's basically an ionic version of nitrogen dioxide. And nitrate is the other one that's NO3 minus. And so reacting the different acids, nitric acid and sodium hydroxide produce sodium nitrate, and nitrous acid and sodium hydroxide produce sodium nitrite. So yes, here. So this was the nitrite and nitrate content that was produced from the charcoal. 5 ppm of nitrite were produced and 10 ppm of nitrate were produced. Nitrites and nitrates are both harmful for the environment, though. So to destroy them, I fed the salts to um, algae and a bacteria called nitrobacter. So nitrobacter oxidizes the nitrite into the nitrate ion, and and the algae converts the nitrate into nitrogen and oxygen gas. Nitrogen and oxygen are, of course, the majority of our atmosphere, so those don't pose any serious harm.
And so, what do you see as some of the practical applications of your project?
Well, one of the most practical applications would be connecting it to the back of not just snowblowers, but cars, trucks, buses, anything that's emitting NOx could use this.
Mm, okay.
The best thing about this is it's so versatile. Whereas in other systems, scaling up or scaling down really adds a lot to the cost. This one could be scaled up much larger without much of an. It would still increase, but the materials are pretty cheap. Like activated charcoal is sold very cheaply as a fish tank, just to remove nitrites and nitrates and other bad stuff from the tank. And at the same time, it can be you can buy a lot of it and scale it up, and it would still be relatively cheap, much cheaper than current methods, which would involve setting up a processing plant on site with a factory. So it could be used practically anywhere.
Wow. Okay. What would you say is the most difficult part of your project?
It was definitely designing the NO2 sensor. The sensor it was there's just so many different problems that I ran into it with it. So initially I was using a sensor called the Mix 6814, and the problem with the Mix 6814 is it's designed for indoor use, which means it couldn't stand up to the temperature. Indoors it was giving perfect readings. I brought it outside and it just gave random readings. So the Mix 2714 was my first choice, but it also has its issues that it's not generally used for hobbyist projects. And of course, I can only solve the ones designed for THT solving.
Did you have any findings that were like unexpected or surprising to you?
Yeah, one of the major ones was just how fast the thing happened. I was really expecting that the charcoal would only last maybe half an hour at max, but the fact that it stayed for almost 75 minutes it was really surprising for me. I didn't think it would last that long. And with such little charcoal, I only used like 50 milliliters. So if you were to put a larger device, it would last pretty long.
Mm-hmm. Just a couple more questions. So, what do you want to do when you grow up? What do you think you may want to study in college?
I'm not exactly sure yet. Um, I really like science, so it's definitely going to be some science, but I'm not sure which one yet. I might take chemistry, or I think I'm going to take chemistry as of right now, but I'm not sure. I might find something else that I like.
Okay. Well, you seem to know a lot about chemistry already, and you're only in sixth grade, so it's quite impressive. So that's really good. Okay. Um, so one last question is, so we had to switch to a virtual format this year for the science fair because of the coronavirus situation. I want to know how that impacted you, or did that disappoint you, or how did you handle it?
I mean, it wasn't really. I was thinking that it might be kind of difficult to get everything virtually and do everything, but it wasn't much harder than doing the regular fair. So there weren't any disadvantages. I do like going to the fair, especially because then there's also I can you can talk with others with the judges. I kind of liked that experience, but this wasn't really anything. It wasn't as bad as I expected. It was really quite good.
Okay.